Hello, I'm BuoyancyVidGhirardelli, and this is my physics lab video on buoyancy. In front of me I have two apothecary jars with approximately 4 liters of water, so the same water, same quantity of water. In front of that I have 2 cans of soda, 1 Coke and 1 Diet Coke. So, I'm going to drop both of these in the water and you're going to tell me what you think's going to happen. Do you think the Coke's going to be higher than the Diet Coke? They're going to be the same, or the Diet Coke's going to be higher than the Coke in terms of floating? Well, now pause the video and guess. Better have paused it. Well, now I'm going to drop them. So, I'm going to put them both in, we're going to see what happens. So, as you can clearly see, the Coke sank all the way to the bottom, and the Diet Coke floated to the top. So if you guessed that the Diet Coke would be above the Coke, the third option, then you guessed correctly. Now I'm going to go into why that is the case. In front of us is the actual science for this. So, as you can see, buoyant force is notarized by F sub B, the force pushing up is notarized by F sub U, and the force pushing down is notarized by F sub D. F sub B, or the buoyant force, is equal to the force pushing up minus force pushing down. And the pressure is equal to the force times the area, which you can derive to be the force is equal to the pressure times area. Following this, we find that the buoyant force is equal to the pressure of the bottom of the can times the area of the bottom of the can minus the pressure of the top of the can times the area of the top of the can. Now, using the hydrostatic gauge pressure formula, we find that buoyant force is equal to the density of the water times the gravity times the height, which is the height is found of the surface of the water down to that point of the can, as demonstrated on the right of the screen. So, substituting this in for the pressure, we find that the buoyant force is equal to the density times gravity times height of the bottom times the area of the bottom minus density of the water times gravity times height of the top times area of the top. And moving things around, since area of the top and area of the bottom are the same, we find that the buoyant force is equal to the density of the water times gravity times the area times h bottom minus h top. And thinking about that, h bottom minus h top is really just the height of the can. So it becomes FB is equal to density, gravity, area, and the height of the can. And the area times the height of the can is really just the volume of the can. So overall, the buoyant force is equal to the density of the water times the gravity times the volume of the can. And as shown on the right side, the mass of Diet Coke is 270 grams, while the mass of regular Coke is 282 grams. And since the buoyant forces are the same for both Diet Coke and regular Coke, since density and gravity and volume are the same or constant for both of them, but the mass is greater for regular Coke, the force of gravity pulling them down is greater for regular Coke, and that's why regular Coke sinks, because the buoyant forces are the same going up, but regular Coke has the additional gravity force pulling it down, causing it to sink to the bottom of the jar. So, in front of me I have 2 glasses of water. Same cup, same quantity of water. The only difference is this cup, the cloudier one, I added iodized salt to. Now, over here I have 2 eggs. So I'm going to drop 1 in the normal cup and 1 in the saltwater cup. And we're going to see the difference. As you can clearly see, the normal water cup, the egg sank to the bottom and stayed there, while as the saltwater cup, the egg is actually floating on the top. Now, this is because, as we found earlier, that the buoyant force of an object comes from the density of the liquid times the gravity enacting on that solid times the volume of that solid. While the volumes are as constant as you can get with 2 eggs, and the gravity is exactly the same, the difference in floating comes from the fact that this water is a lot denser because it has salt in it.